Hello everyone, welcome back. So in this video we are going to understand 2044, the question series we have in the daily series, right? The question is saying that count number of maximum bitwise or subset. It means we have given a array nums and we have to find the maximum possible bitwise or of a subset of nums. Means from the subsets of nums we will first generate, and over that we will find the bitwise, or over that we'll find the maximum one. Okay, maximum possible. What we have to return? We have to return the number of different non-empty subsets with maximum bitwise or. I hope you understand. Means what we have given? We have given nums, we have given, right? The array nums we have given. As you can see here, we have to find the maximum. What maximum? Bitwise or of subset of nums. Understand? Means we have to generate all the subsets of nums, right? And we'll take the bitwise or, and what is the maximum value is coming, that we will return. But return the number of different non-empty subsets with maximum bitwise. Means number of different non-empty. Okay, and this is the subset. What is subset? So an array A is a subset of an array B if A can be obtained from B by what? By deleting some or possibly zero element of B. Two subsets are considered different if the indices of the elements chosen are different. I hope you understand what the question is saying. That means it is saying subset A can be formed from the subset. So means for array A is a subset of array B if it can be formed. Array A can be formed by the elements of B, and so on. The definition is here. You can delete it or you cannot delete it, right? And two subsets are considered different if the indices the element chosen are different. Understand? Cool. Next, it is saying that the bitwise or of an array A is equal to like this. Okay, and this is the nums we have given, and we have to return the possible bitwise, maximum possible bitwise or. So you can see in the explanations we have given the maximum possible bitwise or of a subset 3, right? What is the behavior is 3. There are two subsets of the bitwise or of 3 is 3 and 3 1. So total we are getting 2 here. How we are going to get this value, we'll understand later. If we have triple 2, then what we are getting? 7. If we have this value, we are getting 6, right? We have given some constants we have given, which is very important to understand, and that we will cover in the slides. Okay, let's continue to understand in the deep. So the very first, what we have given the array nums, and what we are asked to do, we have to find the maximum bitwise or value. So you can get from any non-empty subset of nums, right? Means we have to find the maximum bitwise or value, and we can get from where? The subsets of num, right? Then we have to count how many the non-empty subsets gives that maximum or, right? That we have to find. Let's continue. Very first, what we should understand, what is bitwise or, right? So I hope you have gone through this operator, right? Bitwise or, where if you compare the bits, for example, if you compare one bit and we'll do or and 1, you will get 1, right? If any of this is mismatching, right, means 1 0, means first will come what? Coming 1. It is coming what? 0. It means the mismatch case is the 1 is coming first time, it will go 1, right? If it is 0 1, we're getting 1. If any mismatch case coming, it is going to be 1 1, right? But if both are same, 0 0 is there, is 0. In switches, if both are 1, we'll get 1. Either of the switch is 1, we'll get 1, right? If both switch are off, we'll getting 0, right? This was the concept of the bitwise or, right? For example, if we'll take 3 bits 3 and 1, if we'll take, like, let's suppose a 3 digit, and we'll take the bit of 1, what we will get? So for 3, we know that the binary is from 8 4 3 to 1, if we'll put the value is 1 1, right, for 1 1, right, we used to do it, right. How we are converting that, I have explained multiple times, but let me tell you what the how we are used to do in the engineering college, right. So 8 for 2 1 was the formula, where if I want to find the 3, this is for the 3, will do 1 1, rest of the thing will be 0 0, right. So 2 1 is 3, 2 plus 1 is 3, right, and that is why it is become what, 0 1 1. For one bit we'll just make it 1, and rest of the thing will be 0 0, right. So it will become what, 0 0 1. Okay, if you do, if you operate this or, right, 1 1, it will give you what, 1. You are getting 1 here. 0 1, you will get 1, and both the 0 0 you will get 0, right. Means first we have got 1 1, then 1 0, and then 0 0, and you know that what we will get, we'll get 0 1 1. It means what, we'll get 3. I hope you understand the bitwise OR. Okay, let's understand what are the subsets, right. So for any array nums, we have what, 3 and 1. So the non-empty subsets are what? If you take these nums, this is an array, means we have 3 and 1. Two things we have in the array element, at 0 and at 1. So what are the possible uh, subset we will create? Very first we'll take only one element from the array, and that will be nothing but 3, correct. Then subset 3 contains one element, that is 3. So if we'll take only one subset of element, one element, I will take the bitwise, there is nothing other elements, will say we'll get 3. Similarly, we will take only one element of this array, we'll get one subset at 1. Then we are getting what, element is 1, so we'll get only one value, right, on the bitwise OR. Then similarly we have 3 1, if we'll take both, we'll take this one also and this one also, we'll get 3 1 in the subset. Either you ignore or you take it, right, then you will get the subsets elements. Like this, we have the 3 possibilities that we will took, and and then it will get what, the element 3 or 1. So we have already seen with the 3 and or we have taken, we have got what, 3. You just think, you have just seen, right, 0 1 1, and it was 0 0 and 1. But we have got 1, it was also 1, means it is 0. It is what, 3. We are getting here 3. Okay, so can we say that for any array that we have given, right, so it is a non-empty array, right, and so we can form some non-empty subsets. This is the question saying that the non-empty subsets we have to generate, and that will be what, 3 1 3 1, right. So what is the maximum OR? So if you operate on these elements of the subsets, right, what you will observe, you will get 3 1 3, right. As you can see, we are getting at here, and here is the maximum value, right. Maximum OR is what, 3. So there are two subsets that produce. The very first is this and this. Can we say that, right? Let's understand further. So very first, to understand the input and output descriptions is important, right? So input you have given is an array, right? It's a integer array, so we can say array. For example, we have given nums is a 3 1. What output is giving? Output giving is 2. Means 2 subsets we are getting. Just we have seen what, at 3 we are getting, right? This is the subset was there, and this is another was 3 and 1, right? Go back and see. We got at here we get 3 1, 3 1, and this is 3. So both giving out bitwise OR is 3. That is a maximum OR, right? And we are getting what, these two subsets we are getting that produce the result maximum. So we are getting the output here is what, 2. So two subsets gives what, maximum value. What are the subsets are there? 3 and 3 1. Can we say that? And these both are the subsets of original array is 3 1, and both produce what, maximum value 3, right? What is the maximum OR? Maximum OR is 3. Who is generating? This subset and this subset. So this is the input and output we have given. So do not what you call, have fear that I'm getting the digital mathematical questions, right? I am not able to do that. Just trying to understand the basic concept. Bitwise is not a tough questions, right? You have to understand the concept. It is very easy. Let's understand the input. Very first, what we have given. This array we have given, right? What is its length? Length is what? 2. Can we say that? So the possible subsets are what? We have already seen minus 1. We get how many possible subsets we have given? 3. Just that we have already seen. What are the subsets are there? 3, 1 and 3, 1, right? So if we'll take the index at, let's suppose if this is your array 3 and 1, what is the index? Let's call it 0 and this is 1. So from here we'll prepare all the indices. When we prepare indices at 0, when we choosing index 0, right, we are getting what? 0. So these are the chosen indexes we have, right, when we are choosing. So these are the choosing and we are getting this is the subset index. Okay, I hope you understand. Okay, if you'll do the OR calculation, we are getting these values. Okay, and what is the OR result? We will say 3 1 1, and here what we will get is 0 1 1. Correct. Now let's break this into binary to understand the OR, right? Very first we have given subset is 3. So 3 if we operate, right, 3 is equal to 0 1 1 bit, right? We'll take the OR, right? We'll get the 3. Similarly for the 1, if we operate this, we'll get the 1, right? Because there is only one value. For the subset, if you have 3 and 1, if you operate this, you will get 3, that we have already seen. Means we have to find the maximum OR. Okay, next step is to find the maximum OR. So from this above, right, OR values, we have seen what? 3 1 and 3 is coming, right? Here and here I'm talking. Okay, so the maximum OR is what? 3. So can we say that in the next step, what we can do, like we will count the subset with the max OR and count how many subsets gave the 3. So these two are giving 3, and so the output is true. If we'll visualize this in the DFS tree, right? How we'll visualize it? Very first, we are not taking any element, right? From this array, we are not taking any elements. Can we say that? Now we'll take 3 here. So we'll say 3. Another will take, we are not taking anything, right? Then from, if you're taking 3, there is possibility we can take 3 1. We can take 3 1, or we cannot take 1. We will not take 1. So taking 1 means it will come 3 1. If you are not taking 1, it is only 3, right? Then similarly we have, you are taking 1. Yes, you are taking 1, but you are not taking 1. The total sub, if you see the tree, so if you see this tree, you will understand the possibilities. Okay, but the subsets here comes is what? 3 3 came here also and here also, so we can say 3. Then 1 came, we'll say 1, and this 3 1 came, right? So these are the possible subsets, right? We will not count the empty one. If we count the empty one, this is also we have here. So we'll count only non-empty. That the question saying that, right? And if you take the OR, you will get like this. Maximum we are getting at here and here. So we'll get the count 2. I'm making you understood, so you understood the, you can understand the what do you call concept also. Now understand the edge case. If you have the total value is 2 to 2, right? So total subset is what? 7, right? So all combination except empty one. So if we'll take the OR of 2, we'll get 1 0, 8 4 2 1. To get the 2, we'll get only this one, and then these are zeros, right? So 1 0, if we'll take, this is the binary, right? So every sets have OR is 2, right? And that's why we'll get 7, right? So you try this edge case and you will understand, you will get the count 7. Okay, now what you should take away? Very first, generate subset generation you have to do, right? You have to explore all the possible picks, right? So you will generate the what? Subsets. Then bitwise operator, grows as you add more elements, correct? As you have seen, we have taken 3 1, then we are getting only 2, but you operate more value, you will get more values, right? So that is saying bitwise or grows as you add more values, right? So you count the subset that matches the max JOR, okay? And the indices matter because 2 2 from the index 0 1 is different from 2 2, right? So you have to also think about this. So this is the takeaway. You just think about before writing the code. The very tricky part is about the constant we have given, right? So length is giving what is greater than or equal to 1 and less than 16. So what are the possible subsets could be? 2 to the power 16. That is the possible subsets are, these are the subsets. So this is not feasible, but DFS is feasible. If you do the uh, generating all the subsets, right? Trying that was, right? It is not feasible. So we should use the DFS here. This is the first thing you should understand, right? If you do greedy or any other approach you will try, that will not worth. Okay, so better use DFS. It is pre-computed that you have seen the tree. Tree is coming first time, right? Tree came here. So if we'll calculate already, we don't need to calculate here again, right? So that is why we should think about the DFS. Now understand the subset are different by indices, right? Let's suppose so 2 2 from indices 0 1, right? It is different from 2 2 from the index 1 1, because if we have 2 2 2, so this value and this value, this value and this value, right? Both index are different, right? So duplicate values are allowed. So this has 7 non-empty subsets. You try to generate, you will see everything. Okay. Now coming to the solution, right? How we are going to, as we understand, we will use the DFS, right? This is the upper approach. So we'll take max or and count. Okay. Very first, this is our argument that we will take, right? So for example, we'll get all the element will keep trying from here. Let's understand through the example. Let's suppose we have in the nums, we have what? We'll take two things. We'll get 3 and 1. Can we say that? So very first, these are zeros. We'll take these are zeros. Okay. So we'll initialize this value. So max odd is 0 and count is 0. And 3 1 is the nums. Can we say that? So very first, we'll loop the what we call we want to loop to compute the max OR, right? So how we are going to do that? We'll get the 3 first, then 1 first, right? And we'll get the max count. So here from here you will get the max count, right? Let's understand how. When I is at where? At, let's suppose in the very first iteration is at 0, but I we are not taking here. We can say iteration 1. Can I say if iteration is 1, very first iteration, I is not here, so we'll say iteration 1 because this is for each. Okay. When iteration is 1, nums we are getting what? This is your nums. Nums we are getting is what? Is 3, right? First iteration v and the second iteration is 2, right? Then max or will come what? Max or will come what? This is before. I'm talking about before. So before it is 0, right? And max MOA, M before, MOB. We can say max or before, max or after. Okay. It is getting what? It is also 0. For now, just understand. Okay. When it goes to iteration 2, right? What will happen? We are getting the nums is 1. Okay. What is before we have? Max or before? We already have 3. Let's suppose this is 3. 3 or 3, this become now 3 and this become 1. We'll take 3 1. What we will get? We'll get 3. We'll get maximum is 3. I hope you understand, right? That is why we'll, if you'll find the max JOR here, so we'll say max, let's suppose, or we'll get what? 3. Understand? Now we have to call the DFS. The DFS call will do and we'll understand the tree visualization. Okay. Very first, We are calling DFS, we are passing the nums, we are using 0 and 0. Means the index will start from at where? At index 0. Okay, right? Starting index is what? 0. And what is the job value is there? We'll take, job value is what? Is 0. We will take 0 here. And we'll explore all the subsets combination that we have seen, right? What are the combinations there? 3, 1, and 3, 1. Can we say that? These are the possibilities that we have seen. I hope you understand, right? So let's try to understand that. So can I say, I remove this, okay? So very first, let's suppose if we'll do the DFS, okay? I'll take directly 0, 0, okay? So let's suppose when 0, 0, so at num we had 3 and 1, correct? This was the things that we have took in the nums, right? So this is 0, this is 1. When we are talking about the nums at 0, because nums at 0 will include in the DFS also, right? So let's suppose when nums at we have what? 0. What we have is here 3. So if we will use DFS and we'll provide what? 1, comma 0 and 3. Can we say that? What we will get here? 3. This is the first DFS will do. Correct? I hope you understand, right? Then we will include, let's suppose 1. If we'll include nums at 1 this time. Nums at 1. Nums at 1 is what? 1. When we'll do what? DFS will pass 2, then 3 or 1 equal to 3. Can we say that? So we reached the end. Now we reached to the end. So the cursor will also reach to the 1, right? What we got here, we'll get the max or equal to count plus plus. If you go next slide, right, you will observe here. Very first, we'll check, we are passing the nums, index and current or, right? So what we are doing, index is equal to the length. Very first, we'll check if it is equal to this. Means we have to check if the current is coming what? Current order and the max or, if both are equal, right? Means we increase the count now. So it's time to increase now the count. So we have increased the count plus plus. I hope you understand, right? Means what we are trying to do, very first we have nums we have, right? And all each nums will go with 1, 0, 1, right? Will go. I will reach to the there, right? When nums at 0, we are getting the DFS gives 3. When nums at 1, we are getting 3, right? Means we reached here. So each time will increase the count. When nums at what? At 0, we get what we get? DFS gives you 3. Then it also giving 3. Means we are getting the value, right? Both time will increase the count, right? At 3 we are getting the value, at 1 we are getting the value, because we are checking all the values, right? The possibilities. You will try by DFS 1, 0. When you will pass 1, 0, first we have taken for what you call uh, 0, 0, right? It was 0, 0. When 0, 0 was there, then we'll get, then we got for the 1, 1, right? Index. Okay, that time we will not get any count, because when we'll do nums at 1, nums at 1 is what? We'll get 1, right? So that time we'll do DFS is 2, 0 and 1, correct? And here we'll get what? 1. It means we reach to the end, right? And it is not equal to, so it will not increase the count, just will return. We'll check another value, nums at 1, we'll do the DFS 2 and 0, right? Will not get again the count, right? It is not getting the count again. Only when the DFS is at 0, 0, right, we will include nums at 0, which is 3, right, and nums at 1, which is 1, and both gives you the value what? 3 and 3, right? So both time DFS either using what? 2 or 3, right, or DFS 1, 3, right? Both time we are getting the value, and so we are both time we are increasing the count. I hope you understand. Okay, and this time we are increasing the count, index plus 1, we are increasing index. Okay, so if you'll try run the example, let's suppose 3 1 3 is this time, we will take 3 to 1, right? Very first we generate all the empty subsequent subsets, and we'll calculate the OR for each subset, and we'll take the maximum OR, and then we'll count how many subsets match with the OR, right? We are getting the max OR is 3. Now we'll count how many subsets we have, right? So these are the subsets we have. Total we are getting 5. So you check that subsets here, take the binary order or here. So for 3 we are getting this value, like this we are getting all the JOR, right? And then finally we'll return the result. So here we are getting 3 3 3 and 3. We have already understood the example, right? So you can dry run this one, and you have the result here. So pause this, try on your notepad, your notebook somewhere. You will understand how we are calculating here, right? So if you observe that we get result 3 here, how many is there? Here we get, here we get, not here, here we get, here, here, and here. So 4 time here, and 5th is here. So total how many getting the subsets? Total 5 subsets we are getting. I hope you understand. Okay, but if you visualize this these things, right, how we are going to visualize for this one that we have already seen. So very first, when we uh, try the DFS, right, very first, right, at when I equal to 0, that we talk, right, at index 0 we're getting 3. Okay, the next time we have 3 1, right, that time we will get the max 3. Both time we'll get the max 3. But when we are trying at index 1, here at 1 we are getting 1. Okay, so we'll not this is already calculated, so no need to recalculate. Okay, at the time we'll not using the what do you call, non-empty one. Non-empty one we are taking, empty one we're not taking, right? So that is why we'll say total subsets we are getting like this, and that is gives you 3, and this is your output. So let's conclude what we did. We'll calculated the maximum possible JOR using this operator on all elements. We'll use the DFS to explore all the subsets, and then we have count how many of them gave the same OR as max. Why this works? Because it is and can be less than equal to 16. That gives you very big what you call subsets number, right? That we have already seen, and all are non-empty. Okay, so that's all in this video, guys. Thank you for watching on YouTube, and thank you for supporting ExpertFunda. I am seeing that a couple of you are supporting ExpertFunda by liking this video. Please like this video, so ExpertFunda will provide you the better content than other. Okay, and